Okay class, I want to look at one more example of a factored polynomial expression, and then what we're going to do is take the factored polynomial expression and turn it into a standard polynomial expression. That will let us know exactly what power we're on, but it also practices this idea of expanding out the factors. And so behind me I actually have the new function k of x, and k of x is a polynomial expression, many pieces, polynomial. And we can tell right now that it currently has 4 linear factors. We have this one linear factor here, a second here, and then there are 2 of them here we know by the degree of 2. And so we could already say that the degree of this function is equivalent to 2. Degree equals 2. Or not 2, degree would equal 4 because we have 4 expressions. That 2 is just telling us we have 2 of these. This also has 1, this also has 1, total degree of 4. Alright, so degree 4. When we're all done expanding, we should see then something x to the 4th power. Alright, so let's start the process of expanding. In class we learned a couple of different methods to do this. It all starts with the distributive property of multiplication over addition. And that one's telling us that we can multiply through across the whole addition problem. We also talked about a process called FOIL, first, outer, inner, last, is an acronym for doing quadratic factors, or linear factors for a quadratic, for a polynomial expression. And then we also talked about a certain visual way of doing it using boxes. I'm going to first do a little bit of the distributive property, and then I'm going to jump into our boxes to stay organized. So the first thing I'm going to do is I'm going to take care of multiplying this x through to this expression. So I'm going to distribute this x to this x, and I'm going to distribute it to the 4. Now when you distribute, it's the distributive property of multiplication over addition. So I'm multiplying through. X times x is x squared. X times 4 is a positive 4x. See, but it's over addition, so we keep the addition sign. So this is my new factor with the x on the outside. I still have x minus 3 squared right there. Okay, now I'm going to go ahead and work with this x minus 3 squared next, because I can't at this point in time distribute the x squared plus 4x across x minus 3 without first figuring out the 2 of them. So I'm going to rewrite this x to minus 3 squared as x minus 3 times x minus 3. Then you could actually distribute these pieces to the first x minus 3, get that result, and then do one more onto the x minus 3 there. What I'm going to choose to do, though, is take care of this expanding first, x minus 3 times x minus 3, then take care of our final step. And I'm going to do that one actually through the FOIL method. That way we'll see all 3 of our methods. FOIL stands for first, outer, inner, last. So I have my first terms, that's x times x. Those are my first terms of each linear factor. X times x is x squared. Then we go to our outer terms of each factor. That would be the 3 times the 3. Okay? And that would be our negative 9, our positive 9. Okay? Then we're going to our inner terms, that are innermost terms. That's our minus 3x. And then we go to our last terms. Okay, and our last terms that remain here. X times a negative 3 is another minus 3x. And then we'll put this into standard polynomial expression. X squared, we have a minus 3x and a minus 3x. This is x squared minus 6x's. And then put the plus 9 on the end. That's in standard polynomial form. Now this is being multiplied by x squared plus 4x. Alright, so I have one more expansion to do. We've seen the distributive property, we've seen a bit of FOIL, and now we're going to take a look at how we can use boxes to help us here. Here are 2 terms, so I'll make one side of my box 2 wide. Here are 3 terms, so I'm going to make this a 2 by 3 expression. Alright, so here's my 2 side by 3 side, and I'll fill in the sides with the appropriate lengths. This is x squared, this is 4x, here is x squared minus 6x plus 9. Now it wouldn't matter whether I did a 2 by 3 or a 3 by 2, you just have to make sure you use each of the pieces as another part of the box. Now again, multiplication is key here. We have to multiply these terms by this term, making the area of this little square x to the 4th. Hey, that's good, because we need an x to the 4th degree 4 polynomial. We knew that was going to come out there in the end. The next term is x squared times a minus 6x. That would be a negative 6x to the 3rd. X squared times 9 would be 9x squared. This 4x times this x squared would be 4x to the 3rd. This 4x times a negative 6x would become a negative 24x squared. And 4x times 9 would be the 36x. Okay? Now we want to collect all of our like terms, put them together. So I'm going to collect those. I have an x to the fourth. I'll list that first, x to the fourth. Then I have, look, x to the third is on the diagonal here, so I'll collect those, positive 4x and a negative 6, x to the third. So those combine to give me a negative 2x to the third. Our x squareds are on a diagonal as well, negative 24 and a positive 9. So that's going to give me a total of 15, negative 15 x squareds. And then I have this 36x, the only linear term, as a plus 36x. And that is now the standard polynomial form. So our expansion of the original one took 3 different multiplication problems. It took first the x times one of the terms, then it took another of the 2 linear terms to make a quadratic, and then lastly we multiplied this quadratic expression by this quadratic expression to get our final expanded form or standard polynomial form.